A particular sequence is represented by the explicit rule t of n equals 2 times 3 to the n. What are t of 1, 2, and 3? So if I created a quick table of values here, right, I want to know when n is 1, when it's 2, and when it's 3, what is t of n for each one of those? So if n is 1, that's 2 times 3 to the first power, 2 times 3 to the first power, which would be the number 6. If n is 2, that's 2 times 3 to the second power. 3 to the second power is 9 times 2 is the number 18. And then for the last one there, 2 times 3 to the third. 3 to the third is 27. And if I take the number 27 and I double it, so 4, carry the 1, it's 54. So that's going from one representation, an equation, to a table. Next it says graph this sequence, and we're asked what is the domain. Here's a quick graph that I produced in GeoGebra. And the domain of this function, so the domain, it's all real numbers, right? The domain. Yeah, n could be negative. It gets very small. N could be large. So the domain is all real numbers. The range of that function, that's interesting that we weren't asked about the range. The range of this function, is, I didn't ask about the range. The range is not all real numbers, right? The range is everything greater than 0. In fact, it looks like y can't be 0 because there's an asymptote there. But it looks like the range would be everything greater than 0. Next, on the same set of axes, graph the function f of x. I see. I missed something. So thank you. When we see this t of n notation, right, we are assuming this is a sequence, sequence. So when I'm asked what the domain is, it's not all real numbers, right? The domain for this sequence is all integers. So integer, integers. So we're talking like the numbers 0, 1, 2, 3. So the domain of that sequence is all integers. And if I was going to graph it, it would just be these green dots, right? Just the dots are part of the domain, and those are the integers, right? So you could have any integer, like any negative number, any positive number, and that's the domain if we're talking about the sequence. And then we flip it down here and we leave the sequence notation. Now we're saying, okay, consider the function f of x equals 2 times 3 to the x. Exact same rule, but now because we're talking about a function, right, we're no longer restricting our domain. Our domain is not restricted to the integers. And now, because it's a function, our domain is now all real numbers. And it says, how are they different? How are they similar? The two graphs, they're the same shape, right? They're the same shape. They have the same shape. That's a similarity. Same direction. But the big and only difference, right? The big difference is the domain is restricted for t of n, right? For the sequence. For the sequence, we're looking at just those domain values. So there's a restriction in the domain for t of n.